All right, so in this video, we're going to look at deciding if a function is even versus odd, okay? So a function could actually be even, it could be odd, or it could be neither of those, all right? So we're going to start off with even, okay? So the definition of an even function, or a function is even if f of negative x is equal to f of x, okay? So there's two examples below of even functions, okay? And the way you would know that they're even is by evaluating and finding f of negative x, which in this case would be 2 times negative x squared plus 4, which is equal to 2x squared plus 4, which is the same as the original f of x. Therefore, this function is even, okay? So algebraically, you're doing f of negative x. So I'm going to do the same thing for number 2 here, which in this case would mean I'm doing the absolute value of negative x, but that is the same as the absolute value of x, which is equal to the original f of x. Therefore, this function is also even, okay? Now, in order for a function to be odd, okay, I'm going to say a function is odd if f of negative x is equal to negative f of x, or the opposite of the original f of x, okay? So we're still doing f of negative x, but we're seeing what the result is, and we want it to equal negative f of x in order for it to be odd. So for the first function below, f of x equals x cubed minus 6x, we're still going to do f of negative x, which is negative x cubed minus 6 times negative x, which is equal to negative x cubed plus 6. Notice it's the opposite of the entire original f of x, so it's equal to negative f of x. Therefore, the function is odd, okay? Same thing for number 2. If I evaluate f of negative x, okay, I'm doing the cube root of negative x. That's the same as negative cube root of x. That negative could come out, okay? That's equal to the opposite, or negative, f of x. Therefore, the function is odd, okay? So either way, we're evaluating f of negative x. If it's not equal to f of x or negative f of x, then it's not even and it's not odd. We say it's neither, okay? So an example of that would be below here. F of x equals x cubed minus 2x squared. So in this one, if we do f of negative x, we're doing negative x cubed minus 2 times negative x squared. That leaves us with negative x cubed minus 2x squared, okay? Now, I want you to look at that and notice that's, I'm just going to write an arrow off to the side, not equal to f of x. It's not equal to the original f of x, or it's not equal to the opposite of f of x, okay? Okay, because the opposite of f of x would be negative x cubed plus 2x squared. Therefore, it's neither, okay? Okay, so go ahead and try the examples below, all right? Could pause the video, try the examples below, and I'll project the answers to those in a few seconds. Okay. All right, and these are those 6 answers. Okay, so now we're going to go on and look at the graphs. So what you're going to do is go on to 7 and 8 and graph the two functions that are there, okay? And what I want you to do is decide, based on what we just talked about algebraically, whether the function's even, odd, or neither for both 7 and 8. Graph the two functions, and then try to answer the question below to the best of your ability. Looking at the graphs above, what types of symmetry do even graphs have, and what type of symmetry do odd graphs have, okay? Give that a try. Could pause this again, and I will put up the answers to that. Okay. So here's what you should have come up with. Number 7 was even. Number 8 is an odd function. The graphs are there with a few key points. And looking at those two graphs, okay, it ends up being that even functions, like example 7, f of x equals x squared, are symmetric with respect to the y-axis, whereas odd functions like number 8, f of x equals x cubed, are symmetric with respect to the origin, okay? Meaning if you rotate it 180 degrees, the graph looks the same as it originally did, okay? And that's it for even versus odd functions.